So this question is asking you guys, for what values of x is this function a decreasing function? Now, one thing that's really useful to know is, even if you forget what the terminology, like what the pictures actually look like, when something that says decreasing, that means it's actually going down. Now, if you look at this particular graph, you're working with a cubic, and because it's a negative cubic, the shape of the graph is going to look like this. All right, that's what a negative cubic looks like. Now, if you're unsure about this, what you can also do is just go into your graphics calculator and actually draw a graph and just see what it looks like. Negative x to the power of 3 plus 3x plus 2. Okay, now if this happens when it looks a bit funny, just click on F3, which is the view window, and just click on initial, and then it should fix up. So you see, you got a rough cubic shape that's happening there. So the question is actually asking you, for what values of x is it decreasing? So at what points is the graph actually pointing down? It's pointing down here up to this point here, and then after this point, it's actually pointing down. So we already have this visual that when whatever these 2 points are, the one after this point, it's decreasing, and the one before this point is also decreasing. So we already had that visual in our head even before we start the question. So now, if we want to figure out what those points are, we know the gradient at those points are equal to 0. So we need to figure out what values of x is the gradient equal to 0. All right. So the first thing I'm doing is I'm differentiating the function. So when I differentiate this function, I get negative 3x squared plus 3. All right. Just this part is really important, guys. Like I've started noticing that with calculus papers, particularly with excellence questions, just doing this is not going to get you achieved. In this case, the reason you're doing this is because the gradient is actually have to be 0. So you have to go 0 is equal to minus 3x squared plus 3. Now that would get you an achieved. I'm also going to do on the parallel side, I'm going to do the same question, but another way of it. If something is decreasing, then we can say that f dash of x has to be less than 0. Because if the gradient is less than 0, it's actually pointing down. That means it's decreasing. Okay, so you could have also done it like this. You could have actually said, instead of doing the method on the left-hand side, you could have actually done g dash of x has to be less than 0, minus 3x squared plus 3 has to be less than 0. Now I'm actually showing you guys 2 different ways of doing it parallel, so you can see whichever one is kind of working out for you. Now, the next part from here is kind of similar. You've got to actually try and work out for what values of this is actually going to work out. So in this case, I've got 0 equals negative 3 is a common factor. So if I take it out, I get x squared minus 1. Then I can rewrite this as 0 equals negative 3, x minus 1, and x plus 1. And from here, I can say that x minus 1 equals to 0, or x plus 1 equals to 0. So x is equal to 1, and x equals to minus 1. What I've just discovered is these 2 things here are this point. So that's negative 1, and that's positive 1. Now from there, if you have drawn that graph, you can actually you can already come to the conclusion of this question, because you can say that when you got 1, you can actually put and 1, x has to be greater than 1, or when x is less than negative 1. And that right there is your final answer if you were doing the method on the left-hand side along with the shape of the cubic. Okay, you got to have the shape of the cubic there to actually show that you actually understand what it is that you're trying to do. But if you're doing this method in the right-hand side here, then you simplify this. It's going to be negative 3 x squared minus 1 is less than 0. And then write it as x squared minus 1 is less than, sorry, not less than, becomes greater than, because when you go 0 divided by negative a number, that's going to change, the symbol is going to change, right, when you divide by a negative number. So then this becomes x squared minus 1 is greater than 0. And guess what? You still got to factorize, because if we look at this as a graph, you're looking for when is x squared, so actually what I'm going to do is I'm going to factorize this. So I've got x minus 1 and x plus 1 is equal to 0, because I want to try and find out what those 2 points are. And you'll end up with the same ones, negative 1 and positive 1. So that's negative 1, that's positive 1. And you're looking for when is it bigger than 0? So that's basically this zone here and this zone here. So you can actually write this as, just write down and 1, negative 1, the 2 arrows. So you got x is less than negative 1 or x is greater than 1. Is that all right? Can I give you guys a very similar question like this, but instead of decreasing, but I'll give you increasing? Sound like a plan? Okay. So you guys try and do this one. So for what values of x is f of x increasing? And the graph that equation I'm going to give you is f of x equals, now this might not work out to be nice numbers, guys, because I'm just making up these numbers as I go along. Now if you want to see the previous notes, that's the best probably I could do. So you got, actually no, you guys can see that, eh? Hopefully you can. Alright guys, thank you for that. Yeah, the numbers won't work because it's not a nice graph. Try this one instead. I do apologize. Try this, alright? X cubed minus 7x minus 6. Because the other graph had a point of inflection, and so that would have messed you guys up quite a bit. Do apologize. This one should work. How far did you get up to? Okay, so this is a positive cubic graph. So straight away, it's going to look like this. We also know that we're looking for when is the function increasing. So it's going to be that and that, because that's where it's actually positive. So we need to figure out what those turning points are. So we're going to differentiate this. We get f dash of x equals 3x squared minus 7. Now, depending on which way you want to do this, if you want to do it straight away, you can go f dash of x is greater than 0, because if it's a positive, if it's increasing, then that's what it's going to look like. So we can write this as 3x squared minus 7 is greater than 0. So at this point, you need to figure out what those two, you got to factorize this, all right, and find out what those two values are. You can actually, like, there's a little bit of a cheating way of doing this as well. The cheating way of doing this is, instead of doing, all this whole business, I basically do this. Because 3x squared minus 7, it's a parabola, right? And you're trying to figure out at what point it's greater than 0. So what you can do, go to your graphics calculator and just type that equation in. So 3x squared minus 7, and then click on draw. So now you're looking for, let me see if this is going to work. Yes, it is going to work. So what you can do is, come on, work, there you go. I could basically figure out what those 2 points are, because that's the graph, 3x squared minus 7. And I want to know when is it bigger than 0. So it's that zone and that zone. So I just need to figure out what those 2 red points are. To do that, I go back to the calculator, and then I can click on Shift. There's a little button called F5, G-solve. Click on that, and see how there's something called roots? You click on that. So the first value is negative 1.527. And the second value is positive 1.527. Now I'm going to show you all the different ways of doing this. So that's negative, okay, don't write in highlighters. So that's negative 1.52, and that's positive 1.52. The other way of actually getting this is you could have also done it like this. 3x squared minus 7 equals to 0. And then 3x squared equals 7. X squared equals 7 over 3. So x is equal to square root of 7 over 3 plus or minus. And again, that's going to give those two values as well. And I'm going to show you one more thing, how to find those two other values. What you could do is, in your graphics calculator, you actually plot the original function. You know how the original function was, what was the original function? Wasn't it x cubed minus 7x minus 6, right? Now here's the other cheeky way of checking whether you've done the right thing or wrong. Draw it, and there's a little button, go back to GSolve. There's a button called maximum and minimum. Now maximum and minimum is the turning points where its gradient is equal to 0. So if I click on maximum, notice how that value negative 1.52 comes up. And if I click on GSolve again and click on minimum, that's going to give me the other point, which is positive 1.527. So that's another quick way just to do your sketch. Get your 2 points right here, because that's negative 1.52, 1.52. And then you can actually write your answers that way as well. But what they want to see is how you actually got those two red values. But you can actually use your graphics calculator to check your answer if you're doing the right thing or wrong. Oh, Janine, you're here. Okay. But are we actually finished with this question? We're not, because we needed those two zones. So the two zones in this case are when x is less than negative 1.52 and when x is greater than 1.52. So that will be your final answer. Okay, so there's so many different tools you can actually use to solve this one question. Okay, whether you use graphics calculator, whether you use algebraic way, but there's just so many different options. Okay, next question is this. Now we'll come back to this one. Okay, this is a question that we've been doing so far, so have a go at this one. Did you integrate at least? Yes, integrate it. Because you see f dash of x, you integrate it. Basically what we've got is, look at this. This is a straight line. The gradient function is a straight line. When we integrate this, we are going to get mx squared over 2 plus 2x plus c. Now what you did there with the graph, and you know those 2 points, the problem is you don't know if it's actually on the x-axis, because the 2 points that you're given, so for example, the 2 points are 210, which could be here, negative 1, it could be here. Now, we don't know whether this is a positive parabola or a negative parabola. So two things could happen. One, you could have a parabola like this, all right, or like this. We don't even know if it's a turning point. And none of it tells, so we can't really guess and check what this picture is going to look like. The only thing we know is that it goes through 2 and positive 10, and it also goes through negative 1, negative 8. All right? So what you can do is you can set up a series of simultaneous equations. Your first equation is going to be 10 equals m times 2 squared over 2 plus 2 times 2 plus c. So that's this one here. Then the second one is going to be negative 8 equals m times negative 1 squared over 2 plus, stupid graph, get rid of it, plus 2 times negative 1 plus c. All right, so simplifying this, we're going to get 10 equals 4 over 2 is 2, so 2m plus 4 plus c. So this is going to be 6 is equal to 2m plus c. Is that all right? That's for the first point. Now for the second point, you've got negative 8 equals m. Negative 1 to the power of 2 is positive 1. So that's going to be 0.5 minus 2 plus c. So this one here is going to be 0.5m. Negative 2 plus becomes plus 2. Becomes negative 6 plus c. So what I've got here is I've got a set of simultaneous equations. So 6 equals 2m plus c. Negative 6 equals 0.5 m plus c. So because they're simultaneous equations, I want to get rid of the two c's. So I'm going to go c minus c, 2 minus 1.5 m, and then 6 minus of minus 6. So this ends up being 12 equals 1.5 m plus c. Sorry, not c. What am I doing? C minus c is 0. Thanks for telling me, guys. And then m is equal to 12 divided by 1.5. So m is equal to 8. Now figure out what m is. I got to go back and figure out what c is. I can use any equation. I'm going to use this one here because this looks nice and simple. Because 6 equals 2m plus c. And I've got 6 is equal to 2 times 8 plus c. 6 equals 16 plus c, which means c is equal to negative 10. All right? So that means we've actually got our equation. So f of x is equal to 4x squared. I got 4x squared there. Why is it 4x squared? No, wait. It was mx squared over 2, right? Let me write that down again. Mx squared over 2 plus 2x plus c. I think that's what the original equation was when we integrated it. Yep. So then from here we can say that f of x, now m was 8, so 8x squared over 2 plus 2x minus 10. And this simplifies to 4x squared plus 2x minus 2. Minus 10, sorry. So if you found the correct value for c or m, then that ends up being a merit. All right, and the final answer here, putting it together, is your E. Is that all right? Okay, let's do one more different style of question here. If you guys are following on the OneNote, it's the third question. It's this one here. I'm just mindful of time, guys. I might do this. Which one do you guys want to do? Do you guys want to do the velocity question or another curve question? Velocity. Yeah, we've done curves. Let's do this one here. The velocity question. It looks horrible, but once you go through it, it's actually not too bad. Okay? Okay, couple of hints first. This is a really good hint. Now, I know it says the car's speed changes at a rate given by 0.08 meters per second squared. Remember this, acceleration is measured in meters per second squared. Velocity is meters per second. And then distance or displacement is in meters. So that's my first hint to you guys. The second hint is this right here. 3 seconds after, the speed of the car is 5 meters per second. And then the third hint, well, that's not the hint, it's the actual question. So that's all I'm going to give you guys for now. Have a go. And of course, if you have forgotten this, to go from acceleration to velocity, you need to integrate. From velocity to displacement, you need to integrate. That's the last clue I'm going to give you guys. Okay, so the first thing is, I've given you the clue was highlighted in yellow. You've got acceleration is equal to negative 0.808 t. That's what the acceleration is. Now, if I integrate this, I get velocity. So velocity equals negative 0.08 t squared over 2 plus c. And this simplifies to negative 0.04 t squared plus c. All right? Now, what it's telling you is, if you look at that highlighted part, the light blue one, 3 seconds after the brakes were applied, the speed of the car is 5 meters. So that means the velocity at 3 seconds equals 5. So I can rewrite this equation where I substitute 5 and 3, and I can actually figure out what the value of c is. So when I do this, I get 5 equals negative 0.04 multiplied by 9 plus c. I get 5 is equal to negative 0.36 plus c, and then c is equal to 5.36. So the velocity function v of t is now negative 0.04 t squared plus 5.36. What it's asking you guys is, how far will the car travel when the brakes with the brakes applied before it stops. Now, if you think about it, when the car actually comes to a stop, velocity is equal to 0. Okay, now you're trying to figure out how far the car has traveled from the time the brakes were actually applied. But first we need to figure out how long it took for the car to stop. So we're going to put 0 here, equals negative 0.04 t squared plus 5.36. And when we rearrange this, we get negative 0.04 t squared minus 5.36, and t squared equals negative 5.36 divided by negative 0.04. Now this gives me t squared is equal to 134, which means t is equal to 11.58 seconds. We don't need to worry about the plus or minus, because we're assuming that after the brakes are applied at 0, so therefore we're only going to be looking at t when it's positive. Now that's given us for how long it's going to take for the car to come to a stop. It doesn't tell us how far. So what we need to do is take the velocity function and we need to integrate it again to get the distance formula. So that's going to be negative 0.04 t cubed over 3 plus 5.36 t plus c. Now this part is crucial. If you're aiming for excellence, especially with velocity questions or kinematics questions, is at this point you can actually assume that s of 0 is equal to 0. The reason you're assuming that is because you're trying to figure out how far the car actually traveled from the time when the brakes were applied, which means t is equal to 0. So if you think about it like this, here's a graph here. There's my car. Okay? Right there, t is equal to 0. Now the car is actually going along and it's eventually, get off my screen. Wow. Where is it? Eventually it's going to come to a stop somewhere here. And what we're saying is if t equals to 0, s is also equal to 0. So then we can say s of t equals negative 0.04 t cubed over 3 plus 5.36 t. Now we found out that it takes the car 11.58 seconds to come to a stop. So we are going to substitute that as our t. And so when we do this, we should end up getting 41.4 meters. Now, the reason I've actually jumped straight from here to here is because I told you s of 0 equals to 0, right? So watch this. If I put 0 equals negative 0.040 cubed over 3 plus 5.36 times 0 plus c. This entire part becomes 0 because 0 cubed is 0 and then times that. This becomes 0 because 0 times that. So what you end up with 0 equals to c. So that's why I can kind of skip through that step. All right, guys, it is almost time, and I know I've got that one more question. I'll actually do it after you guys leave, and I'll actually chuck it up on the notes if you guys want to have a look at it. Okay? Thank you. All right, guys, so the last question here, what we have is we've got a curve, which is a parabola, because that's x squared. So we know that the parabola is going to look like this. It says it has a turning point when x equals to 2/3. So that's the turning point there. The curve passes through 1, 9. So this point here, we could say that it's 1, 9. And it's saying find the coordinates of the point when x equals to 3. So we've got 3 here, and we're trying to figure out what that is. So the first step I'm going to do is I'm going to differentiate this function here. When I differentiate it, I'm going to get 2px plus q. Sorry, I'm not sure how much I've actually messed up because I forgot to record this. So just to recap, turning point at 2/3, point passes through 1, 9, and they're asking for the coordinate when x equals to 3. All right, so that's what we're trying to do. So we differentiated the function to be 2px plus q. We also know that the gradient at 2/3 is equal to 0. So we can say that 0 is equal to 2p 2/3 plus q. Now, the other thing that we also know is that it has a point, because, I mean, with this equation, you can't really do anything. That's it. You're done. The other thing we know is it goes through 1, 9. So we can say that f of 1 equals to 9, which means 9 is equal to p times 1 squared plus q times 1 plus 2. Rearranging this, we're going to get 7 equals p plus q. So at this point, I'm going to solve these equations simultaneously. So I've got 7 equals p plus q, which is this one here. And then I'm going to take this one, chuck it below it. So I'm going to get 0 equals 2 times 2/3 is 4/3 of p plus q. So what I'm going to do, I'm going to subtract these two equations so I can get rid of the q. So minus, minus, minus. 7 minus 0 is 7. P minus negative 4/3 is going to be negative 1/3 p. And then q minus q is actually equal to 0. So from here I can say that p negative 1p is equal to 21. Or p is equal to 21 divided by negative 1. So what I can then say is that p is equal to negative 21. Now once I got p, I can figure out what q is, because 7 is equal to p plus q. 7 equals negative 21 plus q, and q is equal to 28. So I have the equation of my graph now, which is f of x is equal to negative 21, because that's what p is, x squared, plus qx, q is equal to 28, x, and then plus 2. Now we're asked to find out the y value when x equals to 3. So you're looking for f of 3. That's going to be negative 21 times 3 squared plus 28 times 3 plus 2. And then f of 3 is equal to negative 103. So the x and y coordinates for that point is 3, negative 103. Because if we go back to the question, it says find the coordinates of the point on the curve where x equals to 3. And we have actually done that here. Okay guys, that's basically it for this session here. Do apologize about a couple of mistakes I made earlier on. That always happens when you try and make questions on the spot, but thank you for watching.